Welcome, fellow engineers and curious minds. Today, we're diving deep into one of engineering's most elegant solutions, the timing belt. Just as a conductor orchestrates a symphony, a timing belt conducts the mechanical ballet within your engines and machines. The poetry of power transfer. Imagine, if you will, a river flowing between two cities. Just as the river connects and sustains both communities, a timing belt creates a vital link between the crankshaft and camshaft in an engine. But unlike a river, this connection is precisely calculated, meticulously designed, and perfectly synchronized. The science behind the symphony. Let's break down the mathematical harmony that makes timing belts work. The fundamental relationship between pulleys and belt can be expressed as V equals omega R, where V equals linear velocity of the belt, omega equals angular velocity of the pulley, R equals radius of the pulley. For power transmission, we consider P equals T times omega, where P equals power transmitted, T equals torque. O equals angular velocity, the anatomy of excellence. Unlike their smooth-surfaced cousins, timing belts feature precisely engineered teeth. These aren't just any teeth, they're the product of decades of engineering evolution. Modern timing belts typically use curvilinear tooth profiles, which provide higher power transmission efficiency, up to 98%, reduced noise levels, better load distribution, enhanced durability. Applications. From micro to macro, you'll find timing belts orchestrating precision in automotive engines, synchronizing the dance between crankshaft and camshaft 3D printers, conducting the precise movement of print heads, industrial machinery, coordinating complex automated systems, robotics, enabling precise positional control. The art of selection. Choosing the right timing belt is like selecting the perfect instrument for a symphony. Consider 1. Power requirements. Belt width equals open parenthesis, P times K, S times K, L close parenthesis, / open parenthesis, V times K, T close parenthesis, where P equals power to be transmitted, Ks equals service factor, Kl equals load distribution factor, Kt equals tooth load capacity, V equals linear velocity. 2. Environmental factors, temperature range, chemical exposure, moisture levels, dust and debris. Maintenance, the key to longevity. Just as a violin needs regular tuning, timing belts require careful maintenance. 1. Regular inspection schedule. Visual checks every 5,000 hours. Tension verification monthly. Wear pattern analysis quarterly. 2 warning signs. Unusual. Noise patterns. Visible wear on teeth. Changes in system performance. Timing variations. The future of timing belts. The evolution continues with carbon fiber reinforcement, smart belts with embedded sensors, self-adjusting tension systems, hybrid materials for extreme conditions, engineering philosophy. Remember, fellow engineers, a timing belt is more than just a component. It's a testament to our understanding of mechanical principles. It represents the perfect balance between flexibility and precision, strength and efficiency. When you next design a system, consider the humble timing belt. It might just be the conductor your mechanical symphony needs. Technical reference section, critical formulas for design. 1. Belt length calculation L equals 2, C plus PI times, open parenthesis, D1 plus D2, close parenthesis, divided by 2, plus open parenthesis, D1 minus D2, close parenthesis, squared, divided by 4, CE here L equals belt length, C equals center distance D1, D2 equals pitch diameters of pulleys, 2. Power rating, PR equals PB times Ks times KV times KT, where PR equals rated power, PB equals basic power rating, Ks equals service factor, KV equals velocity factor, KT equals temperature factor. Remember, engineering isn't just about calculations. It's about creating harmony between physics, materials, and human needs. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe to support the channel. Hit the bell icon so you never miss an update. Share this video with your friends. It really helps us grow. Keep me in your prayers. See you in the next one. Coming soon.